Good morning, students. I am Sangeeta, lecturer in chemistry, branch general section, working in GPT Narayan K, semester 1, subject general engineering chemistry, subject code 18C104F. Our topic is fundamentals of chemistry. In that fundamentals of chemistry, our subtopic is atomic structure. Let us recollect what we have discussed in last class. So what we have discussed in the last class? First one, introduction to atomic structure, mass and charge of electron, proton and neutron, what is atomic number, what is mass number, calculation of neutrons, J.J. Thomson model, Rutherford atomic model. Next, come to objectives. On completion of this period, you would able to understand. After finishing this topic, you should able to understand these two topics. That is Bohr's postulates and limitations of Bohr's atomic theory. So today's our topic is Bohr's atomic theory. So before going to Bohr's atomic theory, once again we will revise the theories which are postulated before Niels Bohr. So already I told in the last class. So first theory is J.J. Thomson model. So that is what is J.J. Thomson model. So to explain the structure of an atom, the first theory was given by the scientist J.J. Thomson. As the scientists compared atom with a fruit watermelon, that's why this atomic model is also called as watermelon model. So according to him, atom is sphere in shape, in which mass and positive charge are evenly distributed, and the electrons are embedded within this cloud and vibrate about fixed equilibrium position. So he compared atom with watermelon, and mass and positive charge are evenly distributed and electrons are embedded here and there. So, and this theory has some drawbacks. So we will see what are the drawbacks of this theory. So according to him, electrons are stationary, but electrons are not stationary. That is one drawback. According to him, whole atom is solid, but whole atom is not solid. Most of the part is vacant. That is one term. According to him, positive charge is evenly distributed in the atom, whereas positive charge and mass are evenly distributed. But whereas positive charge is concentrated only on the nucleus. So these are the drawbacks of J.J. Thomson model. As this theory is having drawbacks, one more theory has been given by the scientist Rutherford to overcome the drawbacks of this model. So that theory is called as Rutherford's atomic model. So in 1912, Rutherford introduced his model, and it is based on alpha ray scattering experiment. So he is doing an experiment on alpha rays. So during that time, he accidentally discovered a nucleus. So according to him, the central region of an atom is called nucleus. Inside the nucleus, protons and neutrons are present. These protons and neutrons are combinedly called as nucleons, whereas the electrons revolve around the nucleus like planets around the sun. So here he comparing electrons with planets and nucleus with sun. So how planets revolve around the sun? Like same, electrons revolve around the nucleus. So that's why this atomic model is called planetary model or nuclear model. And come to the drawbacks of Rutherford's atomic model. So this theory also has some drawbacks. So he could not explain hydrogen spectrum. He could not explain the stability of atom. So according to Maxwell electromagnetic theory, every charge moving loses its energy. So what Rutherford said, electrons revolve around the nucleus while revolving. So it is a charged particle. What it should do? It should lose its energy. So when it loses its energy continuously, what happens? The electron will finally come under and fall into the nucleus. When that electron will come and fall into the nucleus, what will happen? The atom will collapse. That means, according to Rutherford, atom is not stable, but atom is stable. So that stability of atom is not given by Rutherford. Then next come to the next theory, Planck's quantum theory. According to Planck's quantum theory, energy is radiated not continuously but discontinuously in the form of packets known as quanta. So what he said, energy is radiating, but how it is radiating? It is radiating discontinuously, not continuously. In the form of what? In the form of packets. That packet is given a name quanta. Quanta is plural, quantum is singular. So in the form of packets known as quanta. So that energy of quantum is given by the equation E is equal to h nu. So where E is equal to energy of quantum, h is equal to Planck's constant, and its value is 6.625 into 10 to the power of minus 27 Earths into seconds, where nu is the frequency. So next, so we'll go to our topic, that is Bohr's atomic theory. So as this theory is Rutherford atomic model is also having some drawbacks. To overcome the drawbacks of Rutherford atomic model, Niels Bohr introduced a theory called as Bohr's atomic theory or Bohr's atomic model. So the scientist Niels Bohr introduced his theory in the year 1913, and this theory is based on Planck's quantum theory and Rutherford's atomic model to explain the spectra in atoms or spectra of atoms. So this Bohr's theory is based on two theories. It is based on Planck's quantum theory and Rutherford's atomic model. So according to Planck's quantum theory, already just now I told, energy is radiated not continuously but discontinuously in the form of packets known as quanta, and that is given by the relation E is equal to h nu, E is equal to energy of quantum, h is equal to Planck's constant, and its value, very important for entrance. What is the value of Planck's constant? That is 6.625 into 10 to the power of minus 27 Earths into seconds, where nu is equal to frequency of energy. Then come to the postulates of Bohr's theory. So we will see the postulates of Bohr's theory one by one. So what is the first postulate? So the electrons in an atom revolves around the nucleus in certain fixed circular paths called orbits. So whatever the electrons present in an atom, so what they will do, they revolve around the nucleus. The central region is called as nucleus. So inside the nucleus, protons and neutrons are present. So what these electrons will do? These electrons will revolve around the nucleus in certain fixed circular paths. So they will not move here and there, like just in circular path only they will move. Those circular paths are nothing but orbits. So whatever the circular path they are revolving, that circular path we are saying it as orbits. Okay, that is the first. And come to second point. Each orbit is associated with a definite amount of energy. That means each orbit is having some fixed energy. Okay, as long as the electrons revolve in an orbit, it does not radiate energy. Hence, the orbits are called stationary orbits or energy levels. So, whatever the electrons are present in an orbit, they revolve in an orbit, but it does not radiate energy. So that's why those orbits are called stationary orbits. So orbits, another name, energy levels. Orbit means, energy level means same. And orbit is also called as shell. Stationary orbits you can say, stationary energy levels you can say, are stationary shells. That means they won't radiate energy when they are revolving in a particular orbit. So that's why those orbits are called stationary orbits. Okay. The next, there are many circular orbits around the nucleus in each atom. Each orbit is denoted by n called principal quantum number. So around So we are saying around the nucleus electrons will revolve. So that whatever the circular path they are revolving, those circular paths are called orbits. So like this, in an atom, many circular paths will be there around the nucleus. So each orbit is denoted by a letter n. That n is called as principal quantum number. If n value is equal to 1, it is the first orbit. Or you can number orbit with alphabets, that is capital letters K, L, M, N. So if n is equal to 1, that is the first orbit, or it is called as K shell. So from starting letter, from K onwards it will start. So K shell, first orbit means K shell. If n is equal to 2, the orbit is second orbit. It is L shell. If n is equal to 3, the orbit is third orbit. It is M shell. If n is equal to 4, the orbit is fourth orbit. N shell, like that. So you can number it as 1, 2, 3, 4, starting from the nucleus, or K, L, M, N, starting from the nucleus. So these are the orbits. Circular paths are called the orbits. Next, as the value of n increases, the size of the orbit as well as its energy also increased. So n value increases means orbit number increases. That is principal quantum number increases. So if it is first orbit means it is smaller. Second orbit means it is somewhat bigger. Then third orbit means it is somewhat like that. So as the orbit number increases, the size of the orbit as well as its energy also increases. Next, the electron revolve around the nucleus only in an orbit in which its angular momentum is an integral multiple of nh by 2 pi. So this point is very, very important and somewhat different and somewhat you feel difficult, but it is not difficult. It will be very easy if you understand. So when the electron will revolve around the nucleus in an orbit, only when its angular momentum. So electron revolves around the nucleus. That means it is having momentum, that is mass into velocity. So here we are considering the radius of the nucleus. So each and every electron is having angular momentum. So angular momentum, how much it will be? It will be is an integral multiple of nh by 2 pi. If this much angular momentum is present, then only it will revolve in that orbit. That is the meaning. The electron revolve around the nucleus only in an orbit. When only in an orbit in which its angular momentum. So its angular momentum will be this much. Integral multiple this. N is nothing but integers. 1, 2, 3, 4. Okay. It is orbit number. So that is given by relation MVR is equal to NH by 2 pi. So understood, students? What is this point? The electron revolves around the nucleus only in an orbit. That means orbit permits the motion of the electron in that particular orbit only when its angular momentum is this much. It is nh by 2 pi. That is mvr is equal to nh by 2 pi, where m is equal to mass of electron, v is equal to velocity of electron, r is equal to radius of orbit. Here don't confuse radius of orbit, not electron. M mass of electron, v velocity of electron. Whereas r is the radius of the orbit. H is the Planck's constant and its value we studied, that is 6.625 into 10 to the power of minus 27 ox into seconds, where n is the principal quantum number. If n is equal to 1, then value will be mvr is equal to h by 2 pi. If m is equal to 2, mvr is equal to 2h by 2 pi. 2 cancels h by pi. So 1, 2, 3, where n is given by 1, 2, 3, 4 and so on. N is equal to 1 means first orbit. If it is in first orbit, this value will be h by 2 pi. If it is in second orbit, its value will be mvr is equal to 2h by 2 pi. 2 cancels, then what happens? H by pi. If n is equal to 3, 3h by 2 pi. mvr is equal to 3h by 2 pi. If n is equal to 4, mvr is equal to 4h by 2 pi. That means 4h by 2 pi means 2 to 4, 2h by pi, like that. So angular momentum of electron is quantized. So whatever this is called as quantization of angular momentum, he said. But what is meant by quantization of angular momentum? He did explain. That is the one of the drawback of Bohr's atomic theory. And why he used this h by 2 pi also, he don't know. So that is one drawback. Okay. So the orbit permits the motion of electron when its angular momentum is integral multiple of nh by 2 pi. So mvr is equal to nh by 2 pi. What is m, what is v, what is r, what is h, what is n, we studied. What is n? Principal quantum number. Principal quantum number means orbit number. N values will be taken from 1, 2, 3, that is integers 1, 2, 3, 4, etc. So if n is equal to 1, its value will be this much. If n is equal to 2, its value will be mvr is equal to 2h by 2 pi. 2 cancels h by pi. N is equal to 3, 3h by 2 pi. N is equal to 4, 4h by 2 pi. So this is called as quantization of angular momentum, or angular momentum of electron is quantized. But what is that quantization of angular momentum? He could not explain. That is one drawback of Bohr's atomic theory. And come to the next point. The electron jumps from lower orbit to higher orbit if it absorbs energy. It jumps from higher orbit to lower orbit by emitting energy. So in the second postulate, we said that So as long as the electrons present in particular orbit, they do not radiate energy. Okay. So when it radiates energy, when jumps from one orbit to another orbit. So it can jump from lower to higher orbit or higher to lower orbit. So when an electron jumps from lower orbit, that means first shell to second shell. It means lower to higher, E1 to E2. And what it will do? It absorbs energy, it takes energy. When it jumps from higher orbit to lower orbit, that is second orbit to first orbit or third orbit to second orbit, what it will do? It emits energy, it radiates energy. So from lower to higher orbit, it takes energy. From higher to lower orbit, it emits energy. So next, the energy of radiation emitted or observed is equal to the difference in energy of the two orbits. It is given by the following equation. It is delta E is equal to E2 minus E1 is equal to H nu. Okay. So what we are saying, when it jumps from one orbit to another orbit, it radiates or absorbs energy. When it radiates, when it absorbs, when it jumps from lower to higher, it absorbs. When it jumps from higher to lower, it emits energy. So whatever the energy radiation emitted or observed is equal to difference in the energy of the two orbits. Okay, so that is first orbit to second orbit is jumping, or second orbit to first orbit is jumping. So the difference in the two orbits is given by this equation, delta E, E2 minus E1, that is second orbit to first orbit. So that E2 minus E1 is equal to, that difference is nothing but whatever the energy it is observing, that is nothing but whatever the energy it is emitting, that is nothing but H nu. Okay, H nu. So where E1 is nothing but energy of lower orbit or first energy level. Energy of first orbit, you can say. E2 is energy of higher orbit or energy of second orbit. H is nothing but Planck's constant, where nu is the frequency of radiation. Okay, so this is about next point, and next come to the next point. Electrons keep revolving around the nucleus in the stationary state as the centrifugal force of the electron is balanced by the electrostatic attraction between nucleus and electron. So what Bohr's theory is saying, electrons are revolving around the nucleus in stationary states, we are saying. So why they are revolving like that? Because some force is acting here on the electrons. So here outside centrifugal force will be acting. So inverse centripetal force is acting. So here electrostatic attraction between nucleus and electron. So all of you know nucleus is a positively charged particle, whereas electrons are negatively charged particles. So nucleus, how positive charge it will get? Inside the nucleus, what are present? Protons and neutrons. Protons are positively charged particles. Neutrons are neutrally charged. So what is the overall charge on nucleus? Protons positive charge, neutrons zero charge. Means on nucleus, which charge it will get? It will get positive charge. Whereas electrons is negative charge. That means here force of attraction will take place. That force of attraction is nothing but electrostatic force of attraction. So here force of attraction taking place means that will come and fall into the nucleus. But what is happening is not happening. So what is happening? They keep on revolving around the nucleus. That means here some force is acting. That force is nothing but centrifugal force. So here this electrostatic force of attraction and this centrifugal force are balanced by each other. So that's why electrons keep revolving around the nucleus in stationary states. So because of that, these two attractions, these two forces are balancing. So that's why electrons are keep revolving. Okay. So these are the postulates of Bohr's atomic theory. So all of you understood? Very important topic. This is for 5 marks for write the postulates of Bohr's atomic theory. So once again, I will repeat Bohr's atomic theory. What is the first postulate, first introduction? Who introduced? Niels Bohr in 1913. This theory was introduced, and this theory is based on two theories, that is Planck's quantum theory and Rutherford's atomic model. So according to Planck's quantum theory, energy is not radiated continuously but discontinuously in the form of energy packets called quanta. It is given by the relation E is equal to h nu, where E is equal to quantum of energy radiated, h is the Planck's constant, nu is the frequency of radiation. The first postulate. The electrons present in an atom revolves around the nucleus in certain fixed circular paths called orbits. So whatever the electrons present in an atom, they revolve around the nucleus like this circular path. That circular paths are called orbits. And each orbit is associated with definite amount of energy. And as long as they present in an orbit, they do not radiate energy. That's why those orbits are called stationary orbits. Orbits another name, energy level or shell. Then next come to the next point. There are many circular orbits around the nucleus. So in an atom, only one orbit, not like that. Many circular paths will be there. So first next to the nucleus, first orbit, next second, next third, next fourth, like that. So many circular orbits will be present. Those orbits are denoted by n. That is, n is given by 1, 2, 3, 4. Digits are KL, MN shells. Okay, next. As the value of n increases, the size of the orbit as well as its energy also increases. N value increases means orbit number increases. The first orbit is smaller, the second one is bigger, the third one is some more bigger, like that its size as well as its energy also increased. And come to the angular momentum. So the orbit permits the motion of the electron in which its angular momentum is integral multiple of nh by 2 pi. It is given by mvr is equal to nh by 2 pi. M is equal to mass of electron, v is equal to velocity of electron, r is equal to radius of orbit, h is equal to Planck's constant, n is equal to principal quantum number. This mvr, 1 means mvr is equal to h by 2 pi, 2 means mvr is equal to 2h by 2 pi, 3 means mvr is equal to 3h by 2 pi, like that. So this is known as quantization of angular momentum, or angular momentum of electron is quantized. Then electron jumps from lower to higher. It absorbs energy. Lower to higher, below to high. When it jumps from higher to lower, from second to 1, third to 2. So it emits energy. Whatever the energy emitting or absorbing is given by difference in the energy of the two orbits. E2 minus E1 is equal to delta E is equal to h nu. So where E1 means energy of lower orbit, E2 means energy of higher orbit, h means Planck's constant, nu means frequency of radiation. So here what he is saying, electrons are keep revolving around the nucleus. How they are revolving in stationary states? Some forces acting here. Here centrifugal force acting, and here centripetal force. It is these two forces are balanced by each other. That's why electrons are keep revolving around the nucleus. So these are the postulates of Bohr's atomic theory. Next, come to limitations of Bohr's atomic theory. So, even though this theory overcome the defects of Rutherford's atomic model, this theory also unable to explain some points. So, this theory also having some defects. So, now we will see the defects of Bohr's atomic theory. So Bohr's theory fails to explain spectra of multi-electron atoms. Multi means more than one electron here. It means it can explain the spectra of atoms containing only one electron. If you take the periodic table, only one electron means hydrogen atom. So, and if you consider the ions helium plus, lithium plus 2, He plus, actually helium atomic number is 2 electrons. Helium plus means it is losing one electron. So it will remain one electron. Lithium plus 2 means here also one electron. So it successfully explained the spectrum of hydrogen atom and some ions like He plus Li plus 2. That means the atoms which are having only one electron or the ions which are having only one electron. That type of spectra only explained by Bohr's atomic theory. But it could not explain the spectra of multi-electron atoms. That means if it is having more than one electron means it could not explain. That is the first limitation of Bohr's atomic theory. Then next, it could not explain fine structure of spectrum. So a fine means multiple structure of spectrum. So in spectrum, you find that some spectral lines, those peaks will be again splitting will be there. The fine splitting of spectrum is not explained. Multiple structure of spectrum is not explained by Bohr's atomic theory. And next come to, it could not explain Zeeman and Stark effects. So in lower classes, you might be studied the Zeeman and Stark effect. Splitting of spectral lines in the presence of magnetic field. Under the presence of magnetic field is called Zeeman effect. Splitting of spectral lines under the influence of electric field is called Stark effect. And these two effects are not explained by Bohr's atomic theory. Then next, it could not explain quantization of angular momentum. Already I told while explaining postulates of Bohr's atomic theory. So there what he said, the orbit permits the motion of electron only when its angular momentum is integral multiple of nh by 2 pi, where n is nothing but integer. Okay, so why there he used h by 2 pi, he don't know. So he told that that is known as quantization of angular momentum. But what is that quantization of angular momentum? He didn't explain. So that is one drawback of Bohr's atomic theory. So he could not explain quantization of angular momentum. Then this theory could not explain the formation of chemical bond. So atoms are less stable. So to get stability, so they will convert into molecules. So atoms combine to form molecules. There what happens? Chemical bond will be formed. That formation of chemical bond also not explained by Bohr's atomic theory. So these are the limitations of Bohr's atomic theory. The first one is it could not explain the spectra of multi-electron atoms. It means he successfully explained the atom contain or ion containing only one electron. And he could not explain fine structure, that is multiple structure of spectrum. Then Zeeman and Stark effects are not explained by Bohr's theory. And he could not explain quantization of angular momentum. And he could not explain the formation of chemical bond. So these are some of the limitations of Bohr's atomic theory. So this topic is important for 1 mark question, 3 marks question, and 5 marks question. Write 5 limitations, that is for 5 marks. Write any 3 limitations, that is 3 marks. Write any 2 limitations, that is half of mark consider, they will consider the 1 mark. So this is also very important for both. Postulates means compulsory 5 marks question. Okay. Next come to summary. In this period we have discussed. So in this period what we have discussed? Bohrs postulates, limitations of Bohrs theory. These are the major topics in that. What is meant by stationary orbits? What is quantization of angular momentum? We discussed. Then come to objective questions. From Bohrs theory, so which type of objective questions you may expect in your entrance? So Bohrs theory explains what? Bohrs theory explains Zeeman effect, Stark effect, spectrum of hydrogen, fine structure of spectrum. So it is under limitation, it is not explained, we said. It is also not explained. It is also not explained. So Bohrs theory explains what? Spectrum of hydrogen atom. So answer is C. Okay. The next, value of Planck's constant. So here many values are given. So here is 6.625 into 10 to the power of 23 joules into seconds. 6.625 into 10 to the power of minus 27 joules per second. 6.625 into 10 to the power of minus 34 joules into seconds. 6.023 into 10 to the power of 23 joules per second. So your answer is 6.625 into 10 to the power of minus 34 joules into seconds. So answer is C. Next, when an electron jumps from its orbit to another orbit, energy is. So when electron jumps from one orbit to another orbit, what happens? Option A, emitted only. B, observed only. C, no effect. D, emitted and observed. So you are not saying either from first orbit or second orbit. So generally they are asking what happens when what it will do. Energy from first orbit to second orbit, not asking from its orbit to another orbit. Or either emitted or observed. Answer is D. From lower to higher means you can say observed. From higher to lower means it can emitted. But from its orbit to another orbit they are asking means either emitted or observed. Next, the orbits in which electrons move according to Bohr. So in which shape the electrons will move. So A, elliptical, B, cylindrical, C, circular, D, oval. In the past as we read, it is in circular paths they move. The answer is circular. Then next, the energy of each orbit is changed, fixed, not same, affected. What is the answer? B. So the energy of each and orbit is fixed. So answer is B. So these are the some of the objective type questions you may expect in your entrance exam. And next come to the questions. So what type of questions you expect from this topic? Very simple, direct question. It is write the postulates of Bohr's atomic theory and write the limitations of Bohr's atomic theory. This question for 5 marks compulsory, very important. And this question either 1 mark, either 3 marks or for 5 marks. So with this we finish Bohr's atomic theory. So understood what is Bohr's atomic theory? Okay, so if you have any doubts, we will clarify in the next class. So this is about Bohr's atomic theory. Thank you, students.